Now, in this short lecture, I will talk about mathematical induction. Mathematical induction is a logical method that makes it possible to prove that a certain property is common to all natural numbers. The proof by induction consists of two claims. First, that number 1 holds the property, and the second, that if a natural number n holds it, then the number n plus 1 also holds it. Okay, so we assume that the claim is true for n, and then we prove it. We prove that the claim is also true for n plus 1. So I will give you an example for mathematical induction. For example, suppose that we want to prove that for all n, 1 plus 2 plus 3 plus 4 plus n equals to n times n plus 1 all divided by 2. Okay, so that claim, we want to prove it for all the natural numbers. So the first step of the induction is actually to check if this claim is true for n equals to 1. So we will check it for n equals to 1. So for n equals to 1, actually that is step 1. For n equals to 1, we prove that 1 is equal to n times n plus 1 is 1 times 1 plus 1 all divided by 2 is 1 times 2 divided by 2 is 1 times 1, that equals to 1. So 1 equals to 1. So we verified that the claim is true for n equals to 1. Then in step 2 In step 2, we will assume that the claim is true for n, so it is the induction assumption that the claim is true for n or 1 plus 2 plus 3 plus n equals so we did the first equation that we assume that the claim is true for n. Okay, so this equation is true. That is our assumption. Okay, and now we'll prove it for n plus 1. Okay, so what we need to prove is that 1 plus 2 plus 3 plus n plus 1 equals to n plus 1 times n plus 1 plus 1 all divided by 2. So we assume that equation 1 is true, that is the claim for n, and we will prove the claim for n plus 1. So this is actually n plus 1 because it is 1, 2, 4, plus 2 plus 3 plus n plus 1 equals to n plus 1 times n plus 1 plus 1 all divided by 2. Okay, so we assume that the claim is correct for n and we will prove it for n plus 1. So actually that is what we have to prove. We have to prove that our claim is correct for n plus 1 because it is 1, 2, plus 2 plus 3 plus n plus 1, we have to prove that the left side of the equation is equal to the right side, and actually here we have, instead of n, we wrote n plus 1. So we have to prove the second expression according to our assumption that the equation 1 is true. This is the induction assumption, that 1 plus 2 plus n equals to n times n plus 1 divided by 2. That is our assumption that this is true for n. And then we have to prove the claim for n plus 1, because it is 1 for n plus 1, because it is 1 plus 2 plus 3 plus n plus 1 equals to n plus 1 times n plus 1 plus 1 all divided by 2. Okay, so that's what we need to prove. So in order to prove it, actually we can substitute the expression in green color by n times n plus 1 divided by 2, because this is the induction assumption. We assume that this equation is true. 1 plus 2 plus 3 plus n equals to n times n plus 1 all divided by 2. So because of the fact that we assume that the claim is true for n, that is the reason that we can substitute this expression in the green color by n times n plus 1 all divided by 2. Okay, so we will substitute it. Okay, we substitute the expression in green by the expression in green color, because we assume that this expression equals to this expression. That is the assumption of the induction. Okay, that is the reason that we can substitute this expression by this expression. Okay, and then we copied n plus 1 here, and actually we have to prove that this expression in the second row equals to this expression. Okay. Now we can open the brackets and do the multiplication. N times n is n squared, and n times 1 is n, all divided by 2. N plus 1, we didn't touch it, it remains as s plus 1, but we can actually multiply n plus 1 by 2 and then divided it by 2. Okay. Okay, here we actually multiplied n plus 1 by 2 and then divided it by 2, so we changed nothing. You can multiply any number by 2 and divide it by 2. You will change nothing, because it is like to multiply something by 1, because 2 divided by 2 is 1. So we multiply n plus 1 by 2 and then divided by 2. Actually, n plus 2n is equals to 3n.
Quadratic equation.
So here we have a quadratic equation, and I hope that you know how to solve quadratic equation. And if you solve this quadratic equation, you will find out that if we actually say that n squared plus 3n plus 2 equals to 0, then it is actually a quadratic equation, and we will solve this equation by the rule of the roots of the quadratic equation equals to minus b plus minus root of b squared minus 4ac all divided by 2a. Okay, so minus b is minus 3 plus minus root of b squared is 9 plus 4ac is 8 all divided by 2. Okay, so this is the how we solve a quadratic equation. Minus b plus minus root of b squared minus 4ac all divided by 2a. So we will get two results. So here we got that minus 3 plus minus 1 divided by 2, minus 3 minus 1 is minus 4, minus 4 divided by 2 is minus 2. So the first solution is minus 2, and the second solution is minus 3 plus 1 all divided by 2. Minus 3 plus 1 is minus 2, and minus 2 divided by 2 is minus 1. So we have two solutions to the quadratic equation. So we can say that here we can write it as n minus minus 2 times n minus minus 1 equals to 0. So n squared plus 3n plus 2 equals to n minus minus 2 times n minus minus 1, or n plus 2 all multiplied by n plus 1. Okay. It is n plus 2 all times n plus 1, so we can substitute this by n plus 2 multiplied by n plus 1. So the last expression is n plus 1 multiplied by n plus 2 all divided by 2, and this is exactly what we needed to prove, that 1 plus 2 plus 3 plus n plus n plus 1 equals to n plus 1 times n plus 2 all divided by 2. Okay, so that was the example for mathematical induction. Okay, thank you very much.